Hello, my name is Darren Thomas and I am the Director of Educational Research Techniques. In this video, we're going to take a look at how to factor trinomials when you have the option of doing perfect squares. So let's go ahead and take a look at how to do this. Now, the ideal of perfect squares is kind of complicated to explain in a simple way, but I'm going to start by giving you the general expression. We'll do a very simple example, and then I will do a complex example where you would have to use perfect squares in order to solve the trinomial efficiently and quickly. So let me go ahead and show you what the expression is for what we use, the pattern. There's a pattern to it. So when we're dealing with this, we're going to use the pattern called a squared plus 2ab times 2ab plus b squared will give us our factor trinomial, which is going to be a plus b, then of course a plus b, like so. Now this does not make a lot of sense right now because it's very abstract, but essentially what's going to happen is that when we actually get our trinomial and we do the steps of the perfect square, what's going to happen is that when we get our final two little terms that we're going to put inside our binomial, if you will, it's going to follow this pattern. And without wasting any more talking, let me go ahead and show you an example. But there's one more thing I want to share with you. If, for example, you have a negative term for whatever reason, instead of having a plus sign here, you would have a negative, and then of course you would have a negative, and also a negative right here also. So let me go ahead and show you the example because we're getting very abstract as already. So my example is going to be as follows. 9x squared plus 12x plus 4. Now, for those of you who are a little bit more comfortable with algebra, you're probably already thinking, hey, we could solve this using grouping. And that's correct, but I want to show you this new process. Now, when you're dealing with solving with perfect squares, the key term is squares. That's the point. And so what you want to do is you want to look at the first term, which is normally, the highest order, and the lowest order term, and see, is there a way that I can square these? What number can I do if I square root these? What will be the term? And so you could probably tell already that if I square 3x squared, I'll just get 3x, like so. And so you can see, let me put that in parentheses like this, and then over here I'm gonna get 2 squared. So basically we're already done, but there's a few more things I want to explain to try to make this a little bit clearer. So now here's where it gets a little bit more interesting. We have a square here and we have a square here. What we can do is we can pull that down and make it a constant in the front like this. What we're doing basically is we're kind of making our 2ab right here. That's what we're doing. And so now next to it, I now have 3x and I have in parentheses also 2. Now here's the thing. If I multiply this information right here, I should get 12x, and you can already see it. 2 times 3x is going to be 6x. 6x times 2 is going to be 12x. So I know I'm onto something. I'm already working out the process here. But wait, there's more. Let me show you on my next slide. So I'm going to rewrite a few things here. My a squared plus 2ab plus b squared. Now, here's where we do something else. This is what I know so far. If you go back here, now notice this 3x, this corresponds to my a term, and this 2 corresponds to my b term. So what I'm going to do now is I'm going to just work everything out as showing you the appropriate steps. So now my a is going to be 3x, we know that, but of course it's squared, plus 2. All right, where did that 2 come from? The 2 came from, remember, when I pulled the square here, the 2, the exponent 2, or to the second power, if you will, I brought it down here, that's where the 2 came from. So now times a is going to be 3x times b is going to be 2 plus, and what's b is going to be 2, and we're going to square that. Now, if we go through all the steps appropriately here, we will get the original answer. But that's not what we want. We want the factored answer. And so that's very, very clear if you look at this carefully. So we have here 3x, because we know this fits the pattern. We can now pull everything out and do the pattern. Remember, when we do the pattern, we're going to get this. We're going to get a plus b, a plus b. I already know my a and my b. The whole reason I did this was to make sure, does what I do fit this pattern that we have for the perfect square? And it does. So since it fits this pattern, I know I can now pull out the a and the b to get my factor term, if you will. So 3x plus, oh, wrong color. Excuse me. Guess the color doesn't matter that much. 3x squared plus 2. 3x squared plus 2. And again, if I were to work this out, you can clearly see the answer. 3x plus 3x is 9x squared. 2 times 3x is 6x. 2 times 3x is 6x, so that's 12x. And then 2 times 2 is 4. It's right there. It's very obvious. But again, as I mentioned at the beginning of this video, this could have easily have been solved with grouping. But the benefit of perfect squares, the benefit of perfect squares in general, is when you're working with big numbers. All right, so let me give you an example here. So let me go here, and I have this problem. So let's say I have 49x squared plus 84xy plus 36y squared. Now, of course, if you're familiar with the grouping method or the AC method, the first thing I do is I multiply 49 by 36. That'll be the number I want to factor. And when I multiply that number, I should get it. But when I add it together, I should get 84. Now, grouping will work, but it's big. 49 times 36, that's got to be, 1,400, 1,500, something like that. It's so big that it's not practical to do on your own by hand. And so what the benefit of perfect squares is in situations like this where you have larger numbers. So we're going to repeat the same process. Let me go ahead and write my little pattern at the top. So it should be a squared plus 2ab plus b squared. And this will give me my factored out terms. A plus b, like so. So what are we going to do? The first thing we're going to deal with, as you should be familiar with, is can I square root these somehow? And you could probably already see that, yes, 49x squared can be reduced or, squared, if you will, to 7x. When you put the square on the outside, and 36y can be reduced to 6y. And we put the square on the outside. Now, just like last time, the square comes out in front as a constant, like so. And now we have 7x, like so, and 6y. Now, if everything is working right, if I multiply all this together, I should get my middle term right here, 84xy. And you can see, we can do some basic math here. 7x times 6y is going to be 42y. 42y times 2 is going to be, 7x times 6y is going to be 42xy. Excuse me. 42xy times 2 will be 84xy. So you can see things are already working out very well. So this is going to be my A, and this is going to be my B term. We're going along very well here. Now, let's check this. We'll go to the next slide. And so I'm just going to write my little pattern up here at the top again. 2ab plus b squared equals a plus b, like so. Now, what do we have here? So for my A, I have the 7x. Let me change the color here, make it a little bit easier for you. Here we go. This is a good one. So I have my 7x, and he's going to be squared, plus 2. Remember, this 2 comes from bringing down the exponent, the square. And then we got here 7x, because that's the A. We got 6y, because that's the B. Plus, then we have 6y squared, like so. So we matched the pattern. This is what we should be seeing. And so now that we know what the A and the B term is, we now know what our factor term is going to be. is going to be 7x plus 6y. 7x plus 6y. Again, you can see the beauty of this, and you can work this out. You can clearly see, just for fun, 7x times 7x is, of course, going to give you 49x squared. So we did this one right here. So then we do 7x plus, times 6y. That's going to give you plus 42xy. And then, of course, we do it again with 6y plus 42xy. And then, of course, then we have to do 6y times 6y. That'll give you 36y squared. If you combine these terms in the middle, you'll get the 84xy. So we can see it works. This is the beauty. Now imagine if you had done this with the grouping method, yes, you would have got the answer, but you'd have been working a long time trying to find factors for 49 times 36. It's very doable. And of course, people who are stronger at math could probably do it even faster. But for, us mere mortals who need shortcuts to get things done efficiently and don't want to spend 45 minutes on a problem, perfect square saves a lot of time here. So let me go back and explain what we did in this video and conclude it. So in this video, we learned about how to factor trinomials using the tool called perfect squares. And so perfect squares follows this very basic pattern here. A squared plus 2ab plus b squared will give you your factor terms. And so what you do is that you look at your first term, the highest power term and the lowest power term, and you try to figure out if there's a way that you can square these. Find, what can I square, do the square root for them. And of course, for this example, it was very simple. Once you get that information, you pull down the square and put it down in front like so, and then you multiply across. And the answer you get here, the product that you get here should be the middle power term, if you will, the that one. And so if that's you're going in the right direction. Essentially, you can stop there and just go right here to factoring it out. However, if you want to check, you can plug everything in and follow the pattern like this and see if it comes out to the original term, the original trinomial. And then when you know that you have the correct A and the correct B, it's just a matter of putting the information in the parentheses. And again, this saves you a lot of time. So, my name is Darren Thomas. I am the Director of Educational Research Techniques. Thank you for watching. Take care.